why did we spend the time to talk about weighted average cost and what debt and equity cost is? Well, the most important reason beyond understanding leverage and the impact is to realize that we need to know what our money cost us in order to determine if the project is going to be viable or not. And how do we do that? Well, we're going to go back to our initial presentation. We have to determine how much capital we're investing in this project to start it, how long we're going to be investing capital before we get a return. What is the annual cash flow returns for each year over the life of the project? Once we've determined that, we're then going to take our cost of capital and apply that against those cash flows. Well, why? It's very simple. Money today is worth more than money tomorrow. A dollar today is worth more than a dollar tomorrow. Currency loses buying power over time. So what we need to do is be able to calculate as reasonably as possible what the real value of those cash flows are over time. Our weighted average cost of capital is the most reasonable estimation of the loss of value or the return that must be given to our shareholders and our lenders each year before we know what nets out to us. So we will calculate our WACC at whatever our cost of capital is and say, each year as the cash flows come in, the first people we have to pay is our lenders and our shareholders. So we take that amount out of each year's cash flow. Then we see if there's anything left that comes to the firm. That's what net present value does. The net present value is a standard calculation that calculates the value of the inflows compared to the value of the outflows. The outflows are our investments, the inflows are our net cash each year. So if we calculate the cash flows in years 1 through 25 on a 25-year project, what's going out, what's coming in, we apply the weighted average cost of capital against those each year to make sure that our suppliers of capital, the shareholders and the lenders, get repaid, and then determine what is left for us. So the straightforward formula is we take the present value of our inflows minus the present value of our outflows. You may recognize that as being very similar to a working capital calculation, where we looked at our current assets and current liabilities. Another way to look at the same information to see on a proportional basis rather than an absolute currency basis whether the project is good or bad is called the PI, or profitability index. Very similar to our current ratio when we were looking at working capital. We take the present value of our inflows, we divide them by the present value of the outflows. So at the bottom of the slide, you'll notice we have a project. We look at the project and we see cash flows of 454.55 and 826.45. Those were the inflows. The outflows were 1,100. We net those out. We come up with a net present value of 181. Is that good or bad? Well, in reality, that's good on its surface, because anytime you have a net present value that's positive, it tells us the project, after all cost of operations, after the annual return to shareholders, after the annual return to lenders, gave us a net cash gain of, in this case, 181. Here's the basic rule. Net present value is positive. The project adds value to the organization. Is 181 enough? That's a different question. That depends on what we're comparing it to. If the basic question is, does this project add value to the organization from a financial standpoint? The answer is yes, 181. If the question is this project good enough to exceed a certain hurdle? Separate question. What's that hurdle? What's the minimum threshold? Is it 0? Is it 100? Is it 1,000? Only knowing that can we answer that question. And the other way to look at this, as we mentioned, was our profitability index. If we look at the present value of the inflows, 1,281, divide that by the present value of the outflows, 1,100, we get the proportion of 1.1645, which means for every dollar we invest in this project, we get $1.16 back, net of all operating costs, all returns to capital. Again, the good news is it's above 1, but we don't know if it's good enough until we know what we're comparing it to. But this is a very good tool to use if we're looking at multiple projects that are mutually exclusive. Perhaps one way to make the choice between project A and project B is to say which one gives us a higher proportional return for every dollar invested. Also, a quick key: if the net present value is positive, the profitability index will be above 1. We're using the same information in both formulas. One we're subtracting, the other we're dividing. So if your net present value is positive, your profitability index will be above 1. If your profitability index is below 1, your net present value likewise will be negative. What we're looking for is a positive net present value and a profitability index above 1 to start with. Then we can look at these in relationship to the benchmarks or the hurdles or the minimum thresholds to determine if the project is good enough compared to those. The other ways to make a decision on a capital project, whether it's good enough or not, is to use the internal rate of return and the modified internal rate of return. Now, the two most common tools for many, many years around the world to judge projects were our net present value and our internal rate of return. Here's the difference between them. With our NPV, we're looking at net cash gain and loss using our weighted average cost of capital to discount or reduce the cash flows in each period. With the internal rate of return, we are calculating what the annual rate is, not trying to determine what the cash gain or loss is. Both tools are used, in fact, all 4 of these tools are used to analyze a project, but their approaches are different. With an internal rate of return, we're trying to calculate the annualized percentage return on the project to compare that to the organization's threshold or hurdle. Where net present value can actually be calculated in Excel manually or using a wizard or writing the formulas, internal rate of return requires an algorithm that's built into the function. You and I don't want to try to calculate an internal rate of return manually. It's a series of interrelated calculations. It would take much too long, and it's not worth the trouble. We literally use the Excel function that is equals IRR, open parentheses, values, comma, square parentheses, guess, close parentheses, close parentheses. What that really means is Excel is able to take the entire range of cash flows from the very first investment, each inflow and outflow for the entire life, all the way to the end of the project. And then it will use that information to calculate for us what an annualized rate of return is on those cash flows. A quick hint, you'll notice in the formula it has the word guess in square brackets. In Excel, anything in square brackets is optional. The function works perfectly well without it. And specifically in this function, there's absolutely no benefit to you or I to guess. If we did, we're telling Excel, we think this is where you should start. And the problem is, Excel is only going to go through a certain number of iterations, calculations, before it stops. If we don't guess, it'll take the cash flows on its face and it'll give us the return. It'll come out as a percentage. Then all we have to do is compare that to what the threshold was. What are we required to achieve? And does this project exceed it? That's the good news with IRR. Here's the bad news. Because of the nature of the function, we do not control the reinvestment of cash flows each year over the project. And what does that really mean? For a 20-year project, what the internal rate of return assumes and forces us to do is the cash flows that come in at the end of year one are reinvested in something else at the same rate that we're predicting here for the remaining 19 years. Cash flow coming in year two gets reinvested for 18, etc. The higher the internal rate of return, the higher the risk to us, because we have to go into the marketplace and find other projects of the same rate to invest in. The higher the rate, the less practical that is. The less practical that is, the more risk inherent. That's the problem with IRR. But here's the good news. MIRR, or Modified Internal Rate of Return, fixes this. This is why more and more organizations are substituting MIRR for IRR. It allows you, the user, to input what rate you want to reinvest those funds at. It's definitely more conservative and more practical. And the built-in function in Excel is equals MIRR, open parentheses, values. So it's using the exact same range of values as IRR did. Then you'll see comma, finance rate. That's your WACC. That's your weighted average cost of capital. Comma, reinvestment rate. That's the rate that you feel comfortable that you'll be able to reinvest those funds at in other projects. Now, what many people do to make it simple is they just make the reinvestment rate the same as their finance rate. We know what return we're giving our providers of capital, and we'll use that same rate. That's fine. Not a requirement, but certainly an option. You can choose any other rate that you're comfortable with. The MIRR will virtually always come out at a lower annualized rate than internal rate of return. But again, we generally have much more confidence in that.